all good. BC Calc. I'm waiting for the record chime. Okay, there it is. All right, you guys. Today we're going to focus on the fundamental theorem of calculus. You can expect to see these types of questions on your AP test. Lots of variations of this to understand if you get the concept. We can make these into procedures, most of these questions, but they'll find a way to throw you a curveball. And so I want you to be understanding this at a very deep level. What is going on in these types of questions, okay? So this is a very, very familiar type of question here. They define one function in terms of the integral of the other, okay? And the first thing I want you to do when you look at this is to see if this is a simple one or if this is a complicated situation. Okay, in this case, they are anchoring this function at -3. And so that -3, because it's a constant, I'm going to refer to that as our anchor. And the reason I'm calling it that is if you think about what this says is, regardless of how complicated this underlying function is, you'll notice that this function is anchored at -3. So if you're asked to evaluate g of -3, as we are here, okay, recognize that by definition, when you're asked for g of -3, that literally means to replace x everywhere in this expression with the number -3. And so you end up with the integral from -3 to -3 of any function at all. Doesn't matter what goes in that integral, in that integrand there. We know that this by definition has to be equal to 0. Okay, so perhaps I should have put this as the very first question. That is an anchor. Okay, the second issue with the way this one is defined is that you'll notice that this matches that those match. And that makes it for a straightforward problem. This is not g of x squared. This is not, having the upper bound of integration at x squared. If these match, that's good. That means it's a straightforward problem. Okay. And of course, when I say straightforward, we know that these are not easy problems, but it's a straightforward fundamental theorem of calculus problem. We can apply the theorems pretty readily without getting ourselves into a lot of muck. Okay. All right. So the first thing it says, evaluate g of 0. So from what we know, that would be just copy this down, at the bare minimum, just copy down what you think it means, and worry about the meaning of it later. Okay. Let's plug this in. Everywhere we see an x, we're going to put a 0. So here we are. Okay, and they're very good about labeling this graph here. They're clearly going to tell you what that is the graph of. That is not the graph of g, that is the graph of f, okay? So looking at this, this is telling us to simply take, for g of 0, we simply take the integral of this function f from -3 to 0. So we start at -3 and we integrate to 0, okay? We're going from -3 to 0, we're going left to right, and so this area being above the x-axis, this area counts as a positive area. And so it's just a matter of calculating, well, what is that area? It's just an area. It's the area under the curve from -3 to 0, okay? So it boils down now to a geometry question, okay? You could write a function here for this and integrate that using the rules of calculus. You could write the equation of this line and integrate that, and that would be a tremendous amount of work. It helps to just look at this as a geometry question. It's basically just saying, what is the area under the curve here? What is that area right there? So we can either use the trapezoid formula or we can just break it down into familiar pieces. It looks to me like if I just make it into a square, a 2 by 2 square, that area, g of 0, is equal to what? 2 by 2, and then plus, and then 1/2 base times height for the area of a triangle. Its base is 1, its height is 2, like so, and we get 4 plus 1, or 5. And there I have it. There's the integral, okay? So that really does count as a straightforward question, okay? All right, I already talked about g of -3. We did that here. This is the anchor of this problem, and if you start integrating at -3 and then you go to -3, there's no chance for any finite area to happen there. And so this is just simply 0. Okay. All right. I'm going to do a couple more, hoping my internet's upholding, and then I'll switch over to the next video. Okay. All right. This is interesting. This one says to evaluate this function f of t dt from -6 to -3. So this is asking us simply for the area under the curve from -6 to -3, okay? And so essentially, it's asking us, well, what's that area? Notice we're going from left to right. We're going from -6 to -3. And when I say under the curve, I have to be careful how I phrase that. This up here would count as a positive contribution to area, but this down here counts as a negative contribution to area, okay? And so just making a sketch of that, we end up with this situation here. This would be a positive contribution to area. This would be a negative contribution to area, okay? And so the area of this piece up here, well, that corresponds to this. That would be a base of 1 and a height of 2. So that's 1, 2. So that area is going to be 1/2 of the base times the height, which is an area of 1 square unit. Okay. And then this area down here is a negative contribution. That area is up here. This is base of 2 and a height of 4. Okay. And I suppose I could argue it's a height of -4. If I want to be completely consistent with my signs and so forth. I think it's easier just to recognize areas of the x-axis we count as positive. Things below will stick a negative sign on them, okay? So this area would be 1/2 times its base 2 times its height 4, or you could argue -4, and that's just 4. And now I just need to be very careful how I add and subtract these. So the original answer is equal to +1, and then this is a -4, which ends up giving me an area of -3. The area under the curve is -3 because there's more below the x-axis than above the x-axis. So that takes care of that one. Okay, explain why the integral from -3 to -6, that's the exact opposite of this, must have the opposite plus or minus sign from our answer in part C. The upper and lower bounds of integration have been switched. Okay, and that's just a rule. If you instead of going from left to right, as we did here, if you go right to left, then things above count as negative and things below count as positive. And so we'd end up with a +4 and a -1, and that would be equal +3. Okay. All right, and then I'll do this one, and then we're going to move on to the next video, okay? Okay, evaluate g of -6. Be sure your answer makes sense in light of your responses to problems C and D. So g of -6, and again, you guys, don't get intimidated by this and say, oh, what are they asking here? Just everywhere you see an x, replace it with a -6, just like you did in Algebra 2, okay? You just replace it. So this is the integral from -3 to -6 of f of t dt, okay? Well, we've evaluated this integral from -6 to -3, and that's the exact opposite of this. And so we know that this is the opposite of the integral from -6 to -3 of f of t dt. And we already worked that out here as a -3. And so it's the opposite of a -3, otherwise known as a +3. Okay, so there it is. All right, guys, I'm going to catch you at the next video. We'll pick up there. Okay. All right. See you then. Okay. Bye-bye.